This is 12.4, our introduction to complex numbers. Today, we're going to learn how to work with them a little bit, add, subtract, multiply, our version of dividing. And then tomorrow, the next lesson, 12.5, is on solving with complex numbers. So let's go over some basics. We have some new vocabulary here. So go ahead and write down this first definition. Our word here is the imaginary unit, and we're looking at this I. And the imaginary unit is the complex number whose square is -1. So what does that mean? Well, it's saying that we're looking at I, we're looking at the square of I, and that is -1. We can think of it this way, or we could think of it as I equals the square root of -1. Now we're going to simplify these three radicals using our I. So how do we do this? Well, the square root of -12 is the square root of 12 times the square root of -1. The square root of 12, let's go ahead and make our little tree. We have a pair of 2's, 3 is by itself. This is 2 root 3. What's the square root of -1? Well, the square root of -1 is I. We're never going to write things as a square root of a negative. We're always going to simplify it down to having something to do with I. For our next example, let's do the same thing. Square root of 25 times the square root of -1. Square root of 25 is 5. Square root of -1 is I. So we end up with 5I. Try example 3. Break it into the square root of 7 times the square root of -1. We can't simplify the square root of 7. And then the square root of -1 is I. Our next definition is that of a complex number. A complex number is a number of the form a plus bi. Something I want us to note is that this a is considered the real part, and the b is considered the imaginary part. Any number can be written as a plus bi. The number 2 can be written as 2 is real, plus 0i. So here we know if b equals 0, then we have a real number, because this piece doesn't exist. We're just a. If a equals 0 and b isn't 0, we just have bi, and this is considered purely imaginary. And now we're going to look at how to plot on the complex plane. So let's go ahead and talk about what does this word complex plane mean. The complex plane looks like an XY axis, except here we have our real and imaginary axes. So if I have a number a plus bi, up here I have a plus bi, my real part, my a, is going to go on the real axis. My imaginary part, my b, is going to go on what we think of as the y-axis. So we think of a plus bi as a coordinate a comma b. And then I can plot a over, b up or down, and that is where my number goes. So we think of complex numbers almost as two-dimensional numbers. We recognize these as the absolute value. When I'm looking at the absolute value of a complex number, the definition is the distance from zero. So, looking at this number, how far away is it from zero? Well, we can picture a right triangle. We have an A distance and a B distance. So doing Pythagorean theorem, a squared plus b squared equals c squared. We end up taking the square root of a squared plus b squared. Let's go ahead and do two examples. Example 1, 5 minus I. This piece is my A. I have a negative 1. This is my B. Draw our real and imaginary line. Remember, these are not the x and y axis. Count 5 over, 1 down. This is where my point is. So we think of it as the coordinate 5, negative 1. Now we're also going to find the absolute value. The absolute value of 5 minus I is a squared plus b squared, taking the square root. What's our a? A is 5, b is negative 1. So it's the square root, 5 squared plus negative 1 squared. And that gives us 26. Well, the square root of 26. Go ahead and try number 2. Number 2, we have our A and our B. So we can think of this as negative 3, comma, negative 2. Negative 3 on our real, negative 2 on our imaginary axes. Here's our coordinate. That's where our number is. When I'm finding the absolute value, I'm going to do negative 3 squared plus negative 2. Let me write that out. Let me start over and try and make sure that fits. There you go. Let me zoom in a little so you can see. So we have negative 3 squared plus negative 2 squared. 9 plus 4 gives me the square root of 13. So the distance from 0 is square root 13. Now that we know how to simplify complex numbers, how to think of complex numbers on the real imaginary axis, and how to find the absolute value, we're going to look at how to perform operations with complex numbers. So adding, subtracting, multiplying. So let's look at example 1. We are going to be adding. And when we're adding with complex numbers, we are combining like terms. 7 and negative 3 gives me 4. Negative 2i plus I gives me negative I. Looking at example 2, we are subtracting. And when we are subtracting, we need to remember to distribute our negative. So we're subtracting. We have to make sure to distribute the negative. So let's rewrite this. I have 1 plus 5i. Distribute the negative, I get a minus 3. Distribute the negative, I get a plus 2i. 1, so let's combine our like terms. 1 and negative 3 gives me negative 2. 5i and 2i gives me 7i. Go ahead and try example 3. It's another subtracting one. We're going to make sure to distribute the negative. So I'm going to rewrite it. 8 plus 6i minus 8. Distribute the negative plus 6i. 8 minus 8 is 0. 6i and 6i gives me 12i. Now we're going to move on to multiplying. Looking at example 4, there's no sign, so this is a multiplying question. Here I have a monomial times a monomial. We can think of it similarly as when we had 7x times 3x. We multiply the 7 and 3, x times x is x squared, so we're going to be doing the same thing. This is just what it's similar to. 7 times 3 is 21. I times I is I squared. Now here, though, we don't just stop. All of our answers have to be in the form a plus bi. So I can only have a power of 1. We do know what I squared is. Looking back at our definition, I squared is negative 1. So we can change that to a negative 1, and I get negative 21. Looking at example 5, this is similar to 2 minus 3i times 4 plus 5i. Well, sorry, x's. When we had x's. So how did we do this? We did our rainbows. So we're going to do the same thing here. 2 times 4 is 8. 2 times 5i is 10i. Negative 3i times 4 is negative 12i. Negative 3i times positive 5 is negative 15i squared. Here, negative 15i squared, we know that I squared is negative 1. So this is negative 15 times negative 1, which is 15. So let's put that instead. What happens with the I squared, what I do kind of, is I cross it out and then change it to a plus. That's what's happening. So this is a plus 15 now. Combine your like terms. 8 and 15 is 23. 10i, negative 12i, minus 2i. Go ahead and try example 6. Negative 4 times negative 4 is positive 16. Negative 4 times negative 5i is negative 20i. Oh, positive 20i. 5i times negative 4 is negative 20i. 5i times negative 5i is negative 25i squared. Those are the 4 terms you should have gotten. This I squared makes this positive. Why? Well, negative 25 times negative 1 is 25. Now I have 16 plus 25, 41. 20i minus 20i is 0. We now have our last definition, that of complex conjugates. So complex conjugates are number pairs of the form a plus bi and a minus bi. So note that the conjugates, it's a pair. It's a pair where one is a plus bi, one is a minus bi. And they're special because their product is a real number. So if we look at example 6, they have that form. The A is the same, one's plus, one's minus, and then the B is the same. And notice when we multiply them, we got a real number, so there was no i's. We're going to use this to do, I'm going to scroll back up. Sorry. We're going to use this to do something called rationalizing, and that's our form of dividing with complex numbers. The whole goal of rationalizing is that we don't have an I on the bottom. So we don't want to have an I on the bottom. So what we're going to do is multiply by the conjugate of the number on the bottom. I'm going to say that again. We're going to multiply by the conjugate of the number on the bottom. So 3 plus 4i is on the bottom. So we're going to multiply by 3 minus 4i. And whatever we do to the bottom, we're also going to do to the top. And now we have to do our FOIL, or our rainbows, however you want to think about it. 15 minus 20i minus 6i plus 8i squared on the top. On the bottom, 9 minus 12i plus 12i minus 16i squared. I squared, that's going to make this negative 8, and this positive 16. So on the top, I have 15 minus 8 is 7, negative 20, negative 6, minus 26i, all over. 9 plus 16 is 25. These cross out. And then we are going to split it. And we split it because I want to know what is my A, what is my B. I'm in the form A plus BI. And there's my answer. Now for number 2, we have something a little different here. We don't have an A. And so there's a couple different things you can do here. The quickest thing to do is to multiply by just I. Why do we just need to do that? Well, I times I is -1 because we have I squared. So that will change this. Let's see how this works. I have I times 4 is 4I. I times -6, -6I squared. All over 5I times I is 5I squared. This top piece is going to become +6 because the I squared changes the sign. The bottom piece is -5. So I have 4I plus 6 over -5. When we're leaving our answer in a complex number, it needs to be an A plus BI. So the I piece has to be last. So we're going to switch these around. And then I'm going to split my fraction. So I have -6 over 5. And then I have -4 over 5I. I want you now to try number 3. Go ahead and pause the video and you can try number 3. Our conjugate that we're going to multiply, this is like number 1. I have an A plus BI. I have 8 minus 7I. Keep the AB the same, change the sign. When I multiply the top, 64, -56I, -56I, +49I squared. All over 64 minus 56I plus 56I minus 49I squared. I know we have a lot going on here. This +49, the I squared, this makes this a -49. -49I squared makes this a +49. Let's look at the top. 64 minus 49, 15. -56I, -56I, 112I. 64 plus 49, 113. And these cross out. That's our whole goal, is for those two to become 0, the i's to go away. I want it in that A plus BI form. I split my fraction. Here's my answer.